We are now ready to talk about the wonderful world of rivets. Rivets are the fasteners that hold your plane together. They are smaller, lighter, and a lot less expensive than nuts and bolts. We must first learn to identify and understand the various kinds of rivets and how they are sized. In the foreground is a blind or pop rivet. Very few of these are used in the construction of your RV, so we will remove this and limit our discussion for now to the solid rivets, which there are several thousands of these to be installed in your kit. There are two general categories of solid rivets: countersunk or flush, and those are designated number 426, and universal head rivets, the ones with the domed head, and those are designated 470. The countersunk rivets are commonly used on exterior metal skins so they reduce the wind drag, and they have a wonderful appearance as they sit flush with the surface. This flush design requires the metal surface on which they lie to be dimpled or countersunk. Universal head rivets, or the domed head rivets, protrude above the surface and can be used where drag reduction or appearance is not important. They have the benefit of not requiring dimpling or countersinking. Identifying rivets by their size and type is an important skill we need to learn. In this picture we have the flush rivets across the top and universal along the bottom. These three sizes of each style reflect the most common diameters you will use in an RV kit. These three diameters, of course, determine the size of the hole that needs to be drilled. The other important aspect of a rivet is its length. A rivet can have a wide range of possible lengths for each of these diameters. Here is a standard numbering system that helps us identify the dimensional aspects of these rivets. We need to be familiar with this numbering system so we can select the proper rivets to use as specified on the plans when building our plane. This chart summarizes the details for understanding the numbering system. The AN specifies that the rivet is of Army-Navy standards. The AN is being replaced nowadays by the letters MS for military standard. These letters are interchangeable with the AN, for example, when ordering rivets from a catalog. The 426 specifies that we need a flush style head on the rivet. The AD is a code that specifies the type of alloy the rivet is made of. AD rivets are specified to be used in your RV plans. The next number specifies the diameter of the rivet in 32nds of an inch. In this case, 4 32nds, or 1/8 inch diameter. The last number specifies the length of the rivet in 16ths of an inch. In this example, 4/16, or 1/4. In addition to selecting a rivet that is proper diameter for the hole in which it will occupy, it's also quite important that the length of the rivet be just right, as the riveting process requires a certain length of tail to be exposed after passing through the material to be joined. The rule of thumb is that the tail length needs to be 1.5 times the diameter of the rivet. This precise length ensures that the riveting process will have just the right amount of material to form the shop head. Your RV plans will specify the proper length rivets for each part of the aircraft. However, you need an easy way to verify that you are using the correct rivet each time. A simple gauge is available that allows you to measure the rivet stem before riveting to ensure you grabbed the right rivet from your collection. This gauge has separate notches for 4 diameter sizes of rivets. You simply choose the notch that matches the diameter of the rivet in question to check if its stem has a length of 1.5 times the diameter. The closer to this ideal length, the better and easier it will be to form a proper shop head. This gauge is sometimes called a go-no-go gauge. Our goal is to squeeze the rivet, which will flatten one end, and this will be called the shop end, resulting in a strong permanent fastener. When the rivet is squeezed or set properly, three things occur. Number one, the tail is turned into a shop head as it expands. Number two, the rivet shank expands to tightly fill up the holes. And number three, the rivet itself becomes work hardened, which means the rivet material actually becomes harder. We have control as to how much the rivet can be squeezed, which results in how big the shop head becomes. The more squeeze, the larger its diameter. To gauge how much squeeze is just right, we need a simple method to measure the shop head diameter. A properly squeezed rivet shop head should be a minimum of 1.5 times the diameter of the rivet. Another check is that the height of the shop head should be a minimum of 1/2 the diameter in height. A simple gauge is available that has these dimensions already calculated. A quick pass over the shop head demonstrates if we have met these standards. If the hole in the gauge is a tight fit on the shop head or cannot fit at all, then the diameter of the shop head has met the minimum 1.5 times the diameter of the rivet. There is a separate gauge for each diameter rivet size. The other end of the gauge ensures that the rivet wasn't squeezed too much. If the horseshoe slot won't fit over the shop end, then the minimum 1/2 times the diameter of the rivet has been met.